So we have the scope option, default gateway, global options, WINS and DNS. Now we also said that we have to set a WINS node type. Well, let's take a look at the 4 node types and see which one you would set and why. Now the 4 node types are B, P, M, and H. You've got B for broadcast node. What that means is that your client will attempt to broadcast to resolve a NetBIOS name to an IP address. Will not use the WINS server. P is peer-to-peer node. That means that the client will attempt to use the WINS server to resolve that NetBIOS name to an IP address, but will not attempt anything else. Won't do a broadcast. The mixed node, it will do both, but it'll attempt the broadcast first. If it can't broadcast, then it'll attempt the WINS query. And then finally we have the H node, the hybrid node, and the hybrid node will attempt to hit the WINS server first, that directed datagram to the WINS server to resolve NetBIOS name to IP address. If it can't find the address in there, the name in there, then it will attempt to broadcast. Now most of the time that's what you're going to want to do, your hybrid node. And the reason is because the WINS server provides us with a certain degree of efficiency. We have a directed datagram sent straight to the WINS server, nice, efficient. We don't have to yell out to the network where everybody feels our traffic. Now one example I can think of where you might want to go with something other than the H node would be, let's say you're on a isolated network segment that's in a remote warehouse somewhere, okay? And most of your traffic is right there local, but sometimes you do need to communicate with the central office across this slow WAN link. Well, I would set that client up in that remote office as a M node, a mixed node, because I want them to broadcast first and try to resolve NetBIOS name to IP address with a broadcast on their local network. And then if they can't resolve with that, let's say they're trying to communicate with somebody at the central office, then they go to the WINS server, which happens to be across that slow WAN link. Okay, so then they attempt that directed datagram to do that NetBIOS resolution. So that's WINS node type. Okay, there's a little bit of a problem. You're thinking, well, what about the fact that you told us that DHCP is a broadcast-driven process, and you have a router. How are you going to be giving IP addresses to these other segments if you're getting the IP address with a broadcast? There's a router in the middle, and we know broadcasts don't go through routers. Well, the answer is with a DHCP relay agent. On all of your network segments that you don't actually have a DHCP server, you're going to set up a DHCP relay agent. Now what a DHCP relay agent will do is it will catch the broadcast, forward it to the DHCP server. The DHCP server assigns the IP address and then facilitates with this relay agent communicating back to that host to give the IP address out. So a relay agent is loaded on any NT machine, workstation or server, and the way you load it is you add the DHCP relay agent service, and then you configure your TCP/IP protocol properties to add the address of the DHCP server that you want to facilitate that coordination with. So where will we need a DHCP relay agent then? Well, we'll need one here, one for this network segment, one for this network segment. So everywhere that there's not an actual DHCP server, every network segment, you'll need a DHCP relay agent. Okay, DHCP sounds great. I think we want to do it. But we have several clients out there, and it's actually the majority of the clients that require an exact address. They have to have .100, .101, .102, because something else is communicating with them, so they need that IP address. But we do kind of like the central control, the central database, so what can we do? Well, the answer is you set up a reservation within your DHCP database. This client right here, static IP address, and it has to have that IP address. Let's say it has to have .100. What we can do is add a reservation in the DHCP database and say every time this client initializes, give it .100. So we just have to say for this exact client, reserve this IP address. Well, what specifies a client? What distinguishes that exact client? How do we know that that's that client? Well, the answer is with the MAC address. The MAC address is the burned-in address on your network interface that uniquely identifies a client. So what we'll do is we'll say add a reservation, type in the MAC address, type in the IP address that we want to reserve. Now, every time this client initializes, he's still dynamic, but he gets that exact address. Now, the benefit of being dynamic is, let's say your Win server changes, your DNS server changes, your default gateway changes. You don't have to actually physically go to that machine to change those parameters. You just change it once in your DHCP scope database. All of your clients, the ones with reservations and the regular DHCP clients, have that new address. Okay, the last thing I want to talk about is how a client can acquire a dynamic address, and then how a client can manipulate the address that he has. Give it up, get a new one. Okay, to get an IP address, you simply go to your network settings, go to the settings for TCP/IP, and click on Obtain IP Address Automatically. Now, once you have a dynamic address, if you want to give that address up and reacquire it, then what you would do is open up a command prompt, type in ipconfig/release to release your IP address, ipconfig/renew to get a new one. Okay, we covered the DHCP process, covered terminology, we covered scope and global options, we covered what you do at the client end to get that IP address, the DHCP relay agent, and a few tips and tricks along the way, reservations, etc. I hope this has been informative for you, and I'd like to thank you for viewing this CBT Nugget.